to describe the structure of software system. You want to get an overview of complex software system and a little hint about its design, if it's built or not. So the city method works like that. This is actually a visualization. So it's something like, you know, you can agree or not and if it's useful. I will try to convince you it is. But it looks like a city, a very abstracted city maybe, but still a city. So it's a domain mapping. What do you mean? You have two domains. One is software, the other one is city. So what you do, build a metaphor, you map concepts from one domain, the domain of software, in this case object-oriented software, to the domain of cities. And you have classes mapping to buildings. Do they look like buildings? Yes, in a way. Then you have packages or namespaces, depending on your language, which map to district. And in the end, the city is your whole system in the end. So you have a little more. For example, you have a little mapping on the metrics, some very simple metrics of buildings. Like, for example, the base size is mapped to the number of attributes of your class, and the height is mapped to the number of methods. So this is different than this because they have, for example, approximately the same number of attributes, but this class is definitely more methods. So you can see that indeed, and they are in one package containing the other. So they are not in the same package. And the other thing that you have is that you have some nesting level mapped to colors in these strings. So this, for example, that I showed you before, is Argo UML. What you can say with this visualization that may help you understand how it works. There are, so let's keep with the metaphor, there are skyscrapers. So what is peculiar about these classes that over here? There are way too many. They are very thin in between. There are a lot of classes like this. What do you think these classes are? They have a lot of methods, but very few attributes. Almost probably zero in this case. Obviously, you have to give a minimum base class, right? These are probably all utility classes, and they're all over there. Probably you can get it from the name, but as you can see, they're also kind of organized somewhere. Also, you have parking lots. Yeah, it's a cool metaphor again. And here, you have just probably collection of constants or something like this. And probably they would be public. They would make no sense to have a lot of private attributes and just that, right? So they're probably constants done for some purpose. In this moment, I don't want to go into. And then you have office buildings. These office buildings and all the other buildings around are all the intermediate states. So in some cases, these, it's not always, but these, for example, when they have this dimension compared to everything else, they are normally correlated, for example, to design smells or to code smells. Like this, it's probably a God class or a blob, depending. So you have to give something more to understand really if this is the case. I'll show you a couple of other examples. This is the JDK 1.5, and it's, again, you have a lot of parking lots here. You have one big class like here, which is, and you don't have a lot of skyscrapers. Actually, this looks like that and so on. But look how different this looks. This is smooth, and is implemented in Smalltalk. So as you can see here, the nesting level of packages is definitely lower. So you have a lower nesting level. And it's implemented in a very different way. But you have classes with a lot of methods, as you can see. Now, just a little advertisement. Try it if you do software and data analysis, and you're not scared by Smalltalk, then you should try this framework. But this is not what we implemented. It's University of Bern. It's very cool. If you have to do any software or data analysis, this is very cool. Anyway, I don't know if I convinced you that this can be useful. Actually, we did a study about it. And this study is called Software System at Cities, a Controlled Experiment. It was presented in 2011 in the major software engineering conference, which is called ICSE, International Conference on Software Engineering. It was in Hawaii. It's a beautiful place. So great thing when you publish this stuff, you get to beautiful places. But anyway, the result is that they give to developers, real developers, not students, they gave it to real developers that had to program some tasks. For example, program comprehension task or design assessment task. And they tried to measure in a controlled way, so trying to be scientific, if the tasks were implemented in a more correct way or in less time. So they observed that if you use this metaphor, if you provide this metaphor to developers, they have somehow a better correctness in what they are implementing, and they have a better completion time of their tasks, whatever they are understanding or implementing something. And the idea is that it's due, they don't know, and we still don't know, if it's due to the visualization itself, or, for example, specifically to the city metaphor. This is very hard to measure, because you would have to give like a different metaphor for visualization, like a tree map, if you ever see something like that. Anyway, we believe that this is more effective. So going back to evolution, actually, this was not talking about the evolution of the system. It was like a static view of the system. But can you do better? Can you show, for example, what is somehow something related to its evolution? You can do it by adding a little more to the visualization, a little more color, for example. You can map colors to the age. So, for example, yellow things here are just added. So you obviously have to map this with the version control system and do a little analysis, which is not so little and not so trivial, with the version control system. And you see that all this blue, it's all in a particular state of, this I think is geodraw. All of these are like veterans, very old stuff, all these packages. And then somehow you have young stuff here, and very young stuff here. So you can see this version, you can see the things that have been added recently, including these skyscrapers up here. They are quite recent. But you can do even better if you augment the granularity. Yeah, a class and see only the number of attributes and the number of methods is not really precise. If you want to see, for example, how it evolves in terms of methods. So this variant is the one with granularity, better granularity, and you have methods like blocks. So you have like a platform that represents the class, and you can represent properties, for example, the class only, and then you have the little boxes, the little cubes that represent the methods. And this is how it looks. So obviously it looks different, but it's not just like that, because now, if you have methods, obviously, and look in the history at a certain point, some old methods may disappear compared to the previous version. So you don't have them anymore. How do you represent something like this? That can help you understand, okay, for example, why this is so tall, and why these are so tall, this is tall again, this is all new, but, So this is why. You can identify, essentially, classes that are very stable on the history. The methods have been added and they stayed there almost for all the lifetime of the project. If you imagine, obviously there is a window here, so it's a little more complicated, and try to keep it simple. This, for example, is young and highly unstable. There are methods that are newer and that have been added, and others, all these holes in between, that have been deleted. There were methods there, but they're not there anymore. So that's why it looks highly unstable, and the color maps it to be something young. Oops. And here, it's very old and very unstable, right? And this, because, there's some new stuff and some old stuff. There are holes, things that have been changing. So if you look like at this and you want to try to find the places where you probably have most bugs, they are very likely to be here. And we did some studies about that. For example, if you take a system like this and you have these classes, pay attention about them, because the problems, the issues are very likely to be there. It's not the only case, but they are highly or quite correlated. So this is not the only way that you can inspect design. What is missing? Your favorite way to determine if a class is bad. What do you think it can be? References to other classes, but when they are, for example, too many, right? So what else? What is your favorite tool to check the quality of your system that you use, if you do? If you program in Java, have you ever used something like Find Bugs? Okay, SonarQube. Who uses SonarQube? That's cool. Okay. There are problems with SonarQube, and try to tell it in a second. But even better, you can think about other humans, okay? Well, the problem is that humans are also a little lazy. And the fact is that it's very complex if a commit is like 500 lines of code. Someone would say, okay, I don't really have time to see if there are issues, and probably it will look fine. If people are very good in doing code review, it may happen something like this, that they're going to complain about everything, and so the quality would be measured in terms of WTF per second, or per minute, sorry, depending on how bad the code is. So we try to say, okay, can we improve the mechanism of code review? And we are going to do this. It's still on the way. I try to integrate, for example, the way that, like, the output of a system like Find Bugs or a system like SonarQube, that essentially they're just giving you reports. So this is what we tried. It's called Design Inspector, or Visual Design Inspector, and unfortunately or fortunately, works only for Smalltalk, for a particular dialect of Smalltalk, because we have developers, we collaborate with developers. So the idea is that you have city visualization again, but then the color of methods is mapped with the violations that you can find with a system similar called Code Critics, which is similar to Find Bugs. And this is how it works. You have a view like this one, and on the left, you have categories of violations. For example, you have something like style. Every code reviewer first checks about style. And if they are shallow, what happens is that they will give you only style violation. Oh, you should indent this better, or blah, 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 something like this. And sometimes you want to get rid of them, for example, and focus on design flaws, like class.references is referenced. In this, there are 5. Inconsistent method classification, which is a Smalltalk thing, which is related to documentation and so on. You have coding idiom violation. You have bugs and potential bugs. So you have things that actually matter. And here, you have the main view, which is the one that I showed you before. But the good thing is that since this is integrated in the IDE, on the right part, you can actually select the method on the view. Obviously, with the hover, you can see which method it is. And you see the rules, and you can modify it in a code browser right down here. You can modify it. There are mechanisms to automatically modify it and fix it, for example. Or for more complex things, you just leave a note and say, OK, this must be really, really checked by someone more expert. But more importantly, also equally importantly, what we can do is we can do a review or code review. So you've done a lot of modification to the code you were reviewing for a system. And then you see, OK, what did I change? And you see the quality values and the number of issues decreasing over time. This is like 30-minute session. And you can check, for example, each modification and see what did you actually modify, what did you actually fix. OK? So this is current research. Current research means that this is just given to developers when trying to understand if developers actually like this. Because like a thing like code critics have been there for ages. And people were not using it because the reports were too long and people started to not care. And you don't really go to fix style issues. You want to see really what matters to you for a specific session, or what matters because you're like trying to fix a bug that you know exists. It involves only some classes. And so we believe that something like this, which is rather simple, it's not hard science, we believe, but it's still very important. It can actually help you for these tasks. So to change, I want to show you this. This is submitted. So this is a view, again, a city view of an IDE, the Faro IDE. I will talk again about it. But here we are mixing different concerns. So I'm coloring not only design issues, but I'm coloring other stuff. I'm coloring together with mixing, blending stuff. For example, when classes appear in stack traces, or classes and methods that are touched by developers, even just opening a window, look at it, reading the code, and so on. So we are merging in this view something called interaction data. And this is the second part. So in the second part, I will be talking about what it makes your coding session actually useful and beautiful and effective. And this is maybe less, it can be less applied with, so there are less applications, direct application, but we believe it has a great potential. So let me tell you what is it about. We work together with a community of Smalltalk developers that develop this beautiful, in a way, IDE, which is called Faro. And we work with them, and whenever you want to implement something that can help them, we work here. So we had this idea, okay, let's try to see how people use this. And let's record stuff. Let's record all the interactions that you have with the IDE. The fact that you save a method, the fact that you open a class, the fact that you open a method, the fact that you type or move the mouse or drag the windows, like everything. It's a little intrusive, but we try to be as fast as possible. So the tool is called dflow. There are a couple of publications with that. If you go to the page of my boss that I will mention in the end, you will find all this stuff. And I can guarantee if you're interested just for culture or for anything else, that these are very easy to be read. They're papers that are written really in an easy way. There's not a lot. You can skip the parts when there is statistics because actually not a lot of people matter. So, for example, for a couple of studies, we recorded 738 sessions coming from 18 developers, who are like 200 hours of recording time and 5 million of events and 14,000 windows. It's not a lot, but it was in a couple of months. So you have to first try to say, okay, in this case, it's just for science, okay? And I'm not going to give you anything better, but in the future, maybe I will. And we try to do something like visualization, but in a different way, because we believe that visualization is valuable. So we constructed this view, which essentially, it describes how you use the UI and what did you do, in the following sense. You have tracks, which represents like a window, or if you consider Eclipse, like a sort of tab on which you're doing something. And a track means that you are doing something for a long time here, and then you move to another tab here, and then to another tab again, and another tab again, okay? So a track is a container, essentially, of windows, or main windows, where you edit and save code, for example, or you inspect, like in a debugger. This is a main, and you have also short-lived windows, like it can be something like a message dialog, okay? Now, the important thing here is that you have also other stuff like window interaction. When it's yellow, you're not actually doing a lot, you're just moving it. And so you can see that sometimes you move the windows a lot because this is an IDE which is based on windows. And so at a certain point you arrive to a mess that you have to reorganize, okay? That's the idea. You have some edit stuff and development activities. So for example, this is an estimation of the time that you spent on understanding, editing, inspecting, doing real important activities. But I will return to that. So one thing you can do is do a little self-reflection. So you have this recording of what you did. You have this visualization. You can look at the visualization and can say, that's what I did. But not only what you did, but also what the characteristic of what you did. We call this, and it's also published last year at Vsoft. It's a conference on visualizing software, okay? And essentially it's called Home Sweet Home because in this session, essentially always focused on one specific window. So it's not that you were working on a single class, but that you had only one entity per time in the case of Faro on which you were working. So it's like your system is not very complicated, or the task you're doing is not so complicated that you need a lot of different parts of the system in the same moment and jumping around to understand what you will be doing. Here you have essentially only one, and everything goes, you go a little away sometimes, but essentially everything focuses here on this main track. This is not done in a systematic way. It's just visual, okay? And it's still important. Window plug. So the idea is that it's a phenomenon that they observed in Faro, but you can observe it even in Eclipse. So at a certain point, you may be doing something hard that you don't know exactly which entities involves, and you will start opening a lot of stuff, and your environment becomes chaotic, okay, like this. So the idea is that once it's in this status, whatever you're doing, at a certain point, you have to close something. You have to cure this, this sort of illness, right, that affects your IDE. And people who studied it, in the past, actually observed something like this in a very interesting way. So in this session, for example, you can see that the task is really more complicated. It's really sequential, so you're moving towards new windows. But at a certain point, you close everything. You try to, diminish the entropy or the chaos of your environment. And this is important for many reasons, because this is like evidence again that this matters and this happens again and people still see it. Finally, it's like a typical session that you say, okay, what did I do last time? I implemented something, changing a little windows and keeping them in the background, but then we have this. It sort of looks like a valley, which is the way that you do in Smalltalk. So you start opening inspectors, which is like debuggers, essentially, where you inspect the contents of an object, and you go down, 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 down. You fix something, because you can edit the code all together in the same window, and then you close everything. It's essentially a session where you implemented something, you're not convinced, and so you're trying to see, debug it a little thing. So that's the idea. We did a little categorization. I won't spend a lot of time, but the idea is that you could take all these sessions and you say, okay, let's try to be a little systematic and say, okay, what are their characteristics? For example, we found session with single tracks, session with multi-tracks, so they have multiple focused windows, so track with the privileged role in the development, and we have sessions which are really fragmented, where each track is really separated by other moving, so it's not really, does not exist any specific track that has a privileged role. So it's fragmented. And then you have a way of moving between tracks, which can be interesting. For example, they can be sequential. So you move between one track to the other in a sequential way. So going from the first track to the second track and the third track, and then you finish. Or it can be a ping pong, let's say, which is like, okay, I do something, then I move, then I go back, then I move, then I go back, and so on. That's the idea. And it can be even between more tracks. It's not just between two. We observed a couple of things. So what did developers do? So these are the results. It probably depends a lot on your system. If you have single tracks or fragmented tracks, for example, or multi-tracks. If your system is complicated, then it's very likely that you will end up, or if your tasks you're doing are complicated, you're like doing complex refactoring in some classes that have a lot of dependencies, then your sessions are very likely to be fragmented. If you're like implementing from scratch, maybe you need only one entity at the moment, and so they will have only one dominant window. And then you have things in between. You also have things that we were not able to categorize in any way because they didn't resemble anything, okay? They were just or irrelevant, too short, or some kind of other problems. And in the track flow, fortunately, somehow, most of them are sequential, which motivates a little even the window plague. Why? Because if it's sequential, it means you do something, then you open another window, then you don't care what you opened before. You open again another window, and another window, and another window. Maybe you could just go on a window that you opened before, but nobody, in this case, cares. So normally, it's really sequential. Your UI having 3 entities open in the same place, and you actually working in all of 3 all together during the session. So what happens? So a lot of developers have more than 50% of their sessions that are single track. But there are a couple of developers that we found that they had like more than 65% of sessions which are fragmented. All of them mostly prefer sequential flow, but there was one that had 43% of ping pong sessions. We don't know why. We didn't go back because it had been probably a little, at the moment, a little too invasive, so we just reported the results. I don't know if you can map some of the experiences to this, or some of your experiences. I would like to hear about if you can relate to some of this. It may seem anecdotal evidence, but actually, not a lot of people try to study this stuff. So to finish the last part, what we are doing, we're trying to do a little mythbusters. In what sense? So people are trying to claim, have you heard the claim that like a program understanding takes up to 50% of your time? Have you ever heard something like this? No? Program understanding. So instead of writing code, so imagine you're writing code for a certain amount of time, then the amount of time you spend on just understanding what you will be doing or what the code does, well, there have been estimates that it takes up to 50%. This is a paper from 1989 by Corby, and it was anecdotal evidence coming from the first, when people actually were trying to study this in the 70s and the 80s. This was the claim. So with the data we have, we try to play a little the Mythbusters, and that's what we did. It's a paper called, with a super cool title, I think. It's I Know What You Did Last Summer, and I hope you can get the reference. Who gets the reference? Okay, very nice. And it's an investigation of how developers spend their time. Again, we took the data, so all the events that I talked to you about, and we tried to generalize them. I tried to reconstruct the activities and what you did, if you edited code, if you did understanding. So I'm not going to bore you with the model. You can read the paper. I'm just presenting you the results. So with a little more sessions than the one that I showed you, we have something like this, which is very surprising, that most of the times the 50% is actually the lower bound. So people spend at least 50% thinking of time thinking. Well, it's not very solid, but it's like there is all a discussion in the threads on when this is valid and when this is not. So we take into account idle times, like the fact that people may go away and talk on the phone, or maybe interrupted for long periods. So this is very likely to be close to the real, but it's more on the amount of this with respect to actual time spent on editing, on typing, let's say, in activities. So don't get scared about this. It's not so strange. The really important things here is this, for example, that people spend a lot of time just moving the user interface, just rearranging the user interface, dragging windows, in the case of Faro, or you can imagine closing tabs, adjusting the view, whatever. So the UI, at least in the case of Faro, impacts at like 15% of time. It changes by developer. This is just an average. And also, there's some time that you spend outside the IDE. Well, you don't know what to do, you go to Stack Overflow, right? You're very lazy, like our students sometimes. You always go to Stack Overflow, even if you know what you're doing, just to be sure, okay? So, but for example, what is the impact of going away with respect to the time that you spend on understanding? So we did a little thing, a little correlation study, which is probably not definite, but it gives, it supports claims that you normally had. So, for example, let's check the fragmentation of the session. How many times you go, how much time you spend outside the IDE. And let's say if it correlates with the time you spend on thinking, on understanding. And we found that this is kind of weak. There is some correlation. So the more you stay outside the IDE, the more when you go back, you spend some time, okay, now how can I do this? This is probably the reason, but obviously you cannot be sure. This is just the correlation. So when this happens, but we don't know why. You can give a lot of interpretation about this. But also, more surprisingly, or not more surprisingly, the number of times that you go outside is more correlated. It has a stronger correlation with the understanding time. It doesn't matter how long you stay outside the IDE, but it matters more how many times you go outside. And then it may even break your flow completely, so that when you go back, you really need to pause and try to understand what you will be doing. Finally, and it's the last thing, it's what is the time spent on outside the IDE, how does it correlate with the way you use the time you spend on arranging the UI? And we found, again, correlation. And why is that? Well, it's probably, again, because IDE sucks. So the IDEs suck. And in the case of Faro, it's not that it really sucks. It's nothing better. So, but still, there's nothing better up to this moment. And so people have to maybe rethink it, because the structure of Eclipse, for example, the structure of Faro, the structure of your average IDE that most of the people use, their UI is the same like in the last 20 years. It didn't change a lot in the case of Faro, if you consider previously Squeak or VisualWorks, if you know what I'm talking about. Also Eclipse, you open it, essentially the UI structure of 10 years ago is not so different. You have a lot of tools and plugins, more, but the structure, the type-based structure is essentially the same. So the idea is that you spend some time outside the IDE, and the point is that you have, I'm almost finished actually. I arranged like probably in 37 minutes, so I hope there are questions because I really would like to answer them. So the idea is that the user interface time, in this case, it increases the more time you spend outside the IDE. So that's the idea. You go back there and you say, okay, what is this mess probably? And you try to rearrange it, or you know what you're going to do. You try to rearrange it in a way that you will support the task you're going to do. Okay? Probably not surprising, but it's one of the first, let's say, empirical evidences. So I hope to convince you that what we do in the ivory tower sometimes can actually impact. And especially for the Smalltalk world, where we collaborate a lot, it's not the only thing we do. But these tools have been used, actually, we get feedback from developers, which are really useful. And in the case of Code City, which is the tool that implemented this, we had even a version that you can probably use with Eclipse. I'm not sure, it's quite an old version, but you can try it out. And if you want to try it, if you're curious. And that's the idea. So obviously, we don't have a lot of resources to maintain many of these tools for a long time. But the good thing about this is that there are companies who actually are implementing this and making money out of this. There are at least 3 or 4 companies that are implementing views like this and selling them like, okay, this is the best way to do system understanding for your project, and you should buy consultancy with us and blah, 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 okay? So this is like, okay, a good sign that probably this mattered, at least in the moment. It's quite an old work, actually, but we still are working on the way you can, for example, exploit visualization or new data new data that involves development, and so on. So I want to spend the last minute talking about, so if you go to Twitter, you will find all of us, all of our group. I suggest if you're going to want to read papers, go to Michele Lanza's website. You will find all the papers of our group. And importantly, the one that involved Code City, the one that I mentioned, the one that I didn't mention that involved all of the other stuff. And I can assure you they can be easily read. And sometimes if you want to follow us, you will also get results like this one. I know, I don't think there are many Smalltalk developers here, but if you're curious to use it for your personal culture or for your for whatever other reason, I think it's a good thing. Smalltalk is still kind of alive. There is a huge community in some countries that is active. So for example, there is a conference in Brescia, it's called ESUG, this July, in the middle of July, ESUG. It's the European Smalltalk User Group. Anyway, thank you very much for your attention. If you have questions, I would like to answer them. 41. Yes.
Have you considered, does it work?
I don't know. Maybe it went away.
Works. Have you considered the city view for the functional programming?
Okay, interesting. So he asked me if I reconsidered the city view for functional programming, how would it change? So if you have a purely functional programming language, probably you would have to adapt the entities to match this particular metaphor. So you would have, for example, functions that are not bound to any particular other entity. So you would have probably to represent it in a different way with a different visualization. So we didn't think about it, but I believe, and I probably would like to investigate to, for example, consider hybrid languages, like it would be something like Scala, where you have both the functional and the object-oriented paradigm that melt together somehow, and that can give you like important and precise and visualization that matter in this case. So we did not, but this is an open area of investigation. And obviously, that's a layer of complexity with respect to what you have to visualize. Yes. Yes.
Can you?
Is this working? Yes.
Can you add to this city also the streets? I mean, the relations between classes?
Yes. So, thank you. There are some works where we try to add relationship between classes that are not streets. They were not streets at the moment. So what happens is that you would have clouds in between. So you'd have lines between the classes here. And this was not really, it was just giving you the order of complexity. And most of the times, really messy things. But we are doing something like this. We are trying, so this is not very organic as a city, right? The districts are like just one inside the other, but they are not streets exactly like you're saying. What we are trying to do, and I don't know, there is a PhD student working on that, is that instead of laying out in this way, which is called rectangle layout, rectangle packing layout, we're going to use a four-space layout to like put the districts in the right places in order to, you know, have it more organic and maybe adding exactly the streets. So you know the two things, if they are connected, they depend together. If they are not connected, they are, for example, independent, okay? With respect to some particular metric of dependency, because you may have different ways of representing that, okay? Okay. Thank you.